Okay, so question 2. Most of this question revolved around solving equations of some sorts, and you've got to know that solving equations means find out what the letter stands for, okay? In general, they'll be using the letter X, finding out what the X is standing for. First question is something that would have been in a year 9 paper, so it's just getting you started a little bit. It's 2 steps. I'm encouraging you to use the balance method at this stage, moving from year 10 into year 11.
Sorry.
Guys, it's going to be a very long video if I'm waiting for people all the time. Alright, so balance method means that you start moving stuff. You start moving stuff from one side to the other. So I'm going to subtract that 7 away, which leaves me a 15. Okay, and without a calculator, that's easy enough to do. I don't have a 7 on the left anymore. I've got 15x over there. Then the next step, well, you can probably tell straight away, but the step that you'd be doing is you'd be dividing both sides by 15. So dividing that by 15 leaves an x left over, and 15 divided into 15 pieces would be 1. You should have enough time to check this. If I was to put 1 back into here and go 15 times 1 plus 7, yes, I'd get 72. So I pretty much know I've got marks in the bank with that question. Okay, part 2 down here. This is easier actually, as long as you realize that p over 4 meant dividing by 4. And when you're solving equations, you're going to do the opposite of dividing, which is to times, right? So p is going to be equal to negative 3 times 4. And you wouldn't have to write this step. If you just went negative 3 times 4 in your head and wrote p equals 12, that would be fine. And again, if you wanted to check negative 12, and that's why I check, I guess. Negative 12 divided by 4 would give me the negative 3 I'm after, so I know that my answer is correct there. Okay, so those are both achievement questions.
I might ask what times 4 on both sides.
Times 4 by both sides, yep.
Is that right?
Yep. So the reason I haven't shown it on the left-hand side is because timesing 4 and dividing by 4 is the cancelling out thing that's happening. So I could show p over 4 times 4 if I wanted to, but I think that's a little bit overkill. So don't quite need to show that step. Okay, part 3 is starting to get a little bit trickier. Bed mass is involved here, so we would be thinking bed mass would normally tell us to do the brackets first. So we'd be adding 3 first, and then we'd be dividing by 2. I'm going to do this question 2 ways, just as practice. Girls? So the first way, using the balance idea, I want to undo the timesing by 2 first. So that would be halving both sides, or dividing both sides by 2. So I've got n plus 3. Don't really need the brackets anymore. You could put the brackets there, don't need to be. Gives me 5. And I think most people would know, oh, it's 2, n is 2. But to do the last step properly, I'd be subtracting 3 from both sides, which would mean that n is equal to 2. So I divided by 2 first, and then I subtracted 3.
Are you supposed to do the 2 times n times 3 thing?
Yeah, okay. So Nick's saying that another way to solve this is to expand, which is a good algebra at school, which would be 2n plus 2 times 3 is 6, is equal to 10.
Oh, right, okay.
And if you solve this problem, you'd still get n equals 2, you'd still get full marks. Alright, but the other way I wanted to show you, and this becomes a little bit more useful once you've got more than 2 steps, is that box method. Okay, where you say, if I was told what n was, the first thing I would do is I would add 3 to it, and that would give me some answer. And then, because it's in brackets, after that I would times by 2. Okay, and the box method is useful because you can go backwards and it's hard to make mistakes with. The result of doing this is 10. The missing thing I want to get to is n in this box, so I've got to go backwards, which means I would divide by 2 to get 5, and go backwards, which means I would subtract 3 to get 2. Okay? I don't know if you would get your mark unless you afterwards wrote down n equals 2. Alright, even though I can see that you found the answer, you've got to attach it to the letter. You've got to tell me what the letter stands for. Alright, so just be safe with that one. Yep.
Does that work for most equations?
It works with all of these ones.
Alright.
Okay, but it doesn't work with question B. So there's a few different techniques going on B. Paradise. Okay. Sorry, well, I'll go around answering more questions a bit later, but I just need to keep it moving a little bit. The problem with this one is that the unknown's in two different places, so that's why this this box method doesn't work, because it would be it'd be tricky to figure out which direction things are going and all of that. This one here, you have to use the balance method of moving stuff from left to right and subtracting and things like that. I really want to get rid of this A. I don't like letters being on both sides of the equation, so I'm going to take it away. I'm going to subtract A from both sides. Now here's a chance for an error. 3A, take away an A. Hopefully you get that right. It's minus 4A when you subtract A. Okay, so that's the step I'm doing at the moment. There's still a plus 5 on that side of the equation. And there's still a minus 3 on this side of the equation. But you can see that this equation, minus 4A plus 5, is looking quite similar to the ones we were doing at the top, which you could just undo stuff to get to an answer. So that's the big step here that makes it a merit question. Okay, so I'm going to do the right things. I'm going to subtract 5 from both sides, so that disappears, which gives me minus 4A is equal to minus 8. Okay, minus 3, take away another 5, takes me back to minus 8. You can see that your negatives are an issue with this paper. If you learn your negative rules of timesing, adding and things like that, you're going to save yourself making mistakes. Alright, there's a minus 4 that's been times by, so I'm going to undo that by dividing both sides by minus 4. Okay, so dividing that by minus 4 leaves me an A. Negative 8 divided by negative 4. Well, 4 divided by 8 is 2. And a negative divided by a negative is a positive, so it's 2. Alright, and you can take the chance to check. If I went negative 3 times 2, I'd get negative 6. Negative 6 plus 5 would give me 1. Alright, let me just write that down. On this side, 2 take away 3 would give me minus 1. Let me check if I did that right. Yeah, I messed up a little bit. Negative 3 times 2 is negative 6. Negative 6 plus 5 is actually minus 1. So both sides of the equation give me the same results when I use 2, therefore I've found the answer. Yep.
When you put it from minus 8 to the other side, which made it 4A, is that, when you make it 3A squared?
3A squared?
Yeah, when you do that, 3A.
You could multiply the whole equation by A at any point and get an A squared. But that's not going to move you anywhere closer to the answer. It's actually going to take you further away. So the right step is to try to undo things, so trying to get rid of the minus 4.
But if you're plussing it, so we go 4A, and if you're timesing it, is it A squared?
Yes. Okay, let's keep going, guys. Alright, so part 2 of that question. These ones I want to learn as well. This is a quadratic, but it's a factorized one. Okay? And there's this rule that if you ever are asked for two numbers that multiply to be 0, the only ways that could happen is either if it's 0 times something, or if it's something times 0. Okay, that's the only way you can make 0 by multiplying things. So that tells us that p minus 4 could be equal to 0, that would be an answer, or p plus 5 could be equal to 0, that would be an answer. Now there's a shortcut with these. You just look at the last number and you take the opposite of it. So the opposite of minus 4 is positive 4. So p equals 4 will be an answer to this question. Okay, that basically makes the first thing 0. The other one is the same. I could make this 0 by using minus 5. So p could also be equal to minus 5. There are two answers to this that you need to give to get your full marks, which I think is a merit. Alright, part 3 is actually the same type of question, but there's more work involved in it. It's a quadratic because it's got this squared stuff in it. And even onto part C it's got that. So we'll practice this a little bit. There is a step that I can do before I get started. You might notice that every part here is an even number. So I could divide the whole equation by 2 and that would be okay. So if I halved 2p squared, I'd get p squared. If I halved 4p, I'd get 2p. And if I halved 16, I'd get 8. So you're allowed to take an equation and do something to every piece of it. That's alright, as long as you do it to every piece. Now this doesn't look that helpful because I would have to undo a squared and a 2 times 2, and that's not really possible. So what I'm going to do is whenever you've got a squared equation, complicated like this, you move everything to one side so it looks a bit like that. So you get an equals 0 type of equation. So I'll leave this stuff over here as it is, but I'm going to take the 8 to the other side. And what happens when it comes to the other side? Negative. Yep, it becomes a negative because it was a positive on this side. Alright, now that's not easy to solve yet until we try and put it into one of these. Okay, so a quadratic equation like this, if you can put it into brackets, then you can do what we did up here, you can solve it. Alright, so with these ones, if there's a squared thing, that goes at the front of each bracket. And then you're asking yourself about the last one. What multiplies to give me negative 8? Because when you do the expanding step, you end up multiplying the last two numbers to get this. So what multiplies to give me negative 8? 2 and minus 4? What else? Minus 4 and 2? Well, that's the same actually.